Hi dear students, welcome back to e-classes. Myself Santosh Vijay. In previous class we discussed about the level up automations. Today shall we discuss about the process industry versus discrete manufacturing. As we can see the image, dear students, here we have a table, automation levels for process and discrete industries. Dear students, having the understood the basic elements and contents of automations, we now look in more detail at industrial control systems. We divide industries and their production operations into a process industries and discrete manufacturing industries. These labels helps the describe the sorts of automation that occurs in each type of industry. The table details the two industry types and their respective automation uses for each level of automation. That could be we should understand through the table. As we can see the table, level 5 is there. In level 5, the process industry automation, the corporate level, as we can discuss in previous class, level 5 is an corporate level. Management information systems, strategic planning systems, high level management of enterprises. And now coming to the discrete manufacturing industry automation, the corporate level, the management information systems, strategic planning systems, high level management of the enterprises. Coming to the level 4, in the process industry automation, a plant level, which is a plant level scheduling, tracking materials and equipment monitoring. As coming to the discrete manufacturing automation, the plant or factory level, which is a fourth level in discrete manufacturing automation, scheduling, tracking, working process, uh, routing parts through the machines and machine utilization. Coming to the level 3 in process industry automation, supervisory control level, which is a supervisory control level, the control and coordination of several interconnected unit operations that uh, make up the total process. In coming to the discrete manufacturing industry automation, the manufacturing cell or system level, control and coordinate of groups of machines and supporting equipment working in coordination, including material handling equipment. Coming to the level 2 in the process industry automation, regularity control level, which is a regularity control level, the control of unit operations. Coming to the discrete manufacturing automation, the machine level, which is a machine level. Level 2 is a machine level. Here the production machines are workstations for the discrete parts and product manufacturing. Now coming to the level 1, which is a device level, as we can discuss earlier, sensors and actuators comprising the basic control loops for the unit operation in process industry automation. And coming to the discrete manufacturing industry, the level 1, which is a device level, the sensors and actuators to accomplish the control of machine actions. Hope you understand the both the industries. Now coming to the uh, a significant variation exists at a lower level, owing to the differences in the device and equipment used in two industries. At higher levels, the control of the unit or the control of the machinery provides the basics for the difference between the levels 2 and 3. Levels 4 and 5 are in a comparison fairly similar across both the process industries and discrete manufacturing industries. Thus, automation is applied differently across process industries and discrete manufacturing industries, especially at the lower level of automation. The variable and parameters used by the productive operations of the two industries also differ significantly. In the process industries, the variables and parameters tend to be continuous. In a discrete manufacturing industry, they tend to be discrete. A continuous variable or parameter is one that is uh, uninterrupted as a time proceeds. It is considered to be analog that is it can take on any value within a certain range. For examples include force, temperature, flow rate, pressure, and velocity. A discrete variables or parameter is one that can take on only a certain values within a given range. The most common example are binary, open or close or on or off, and etc. And discrete other than a binary, that is it can take on a more than two possible values but less than an infinite number. In a process industry, the variables and parameters tend to be a continuous control. In a discrete manufacturing system, they tend to be a discrete control, as we can discuss before. Okay, now coming to the uh, continuous versus discrete control. There are two types of control: continuous control and discrete control. In a continuous control, the variable and parameters are continuous and analog. In a discrete control, the variables and parameters are discrete, mostly in a binary format. Continuous and discrete control factors are compared in a table as given below, dear students. That is, the table is a continuous and discrete control. Coming to the first column is a factor, product output measures. In a continuous control process, weights, liquids, volumes, solids, and volumes. In this discrete control system manufacturing, number of parts and products. And quality measures in a continuous control, the consistency, solution concentration, absence of contaminants, specification, conformance. In discrete control, dimensions, surface finish, appearances, absence of defects, product reliability. And coming to the variables and the parameters into the continuous control process, the temperature, volume, flow rate, and pressure. In discrete control, position, velocity, acceleration, and force. In sensors, continuous control system, flow meters, thermocouples, pressure sensors. In discrete control system, limit switches, photoelectric sensors, strain gauges, piezoelectric sensors. In actuators for the continuous control process, valves, heaters, and pumps. For discrete control system, switches, motors, and pistons. Process time and constraints. In control process, seconds, minutes, and hours. In discrete control, less than a seconds. Hope you understand, dear students. In a reality, a combination of both control types actually exist in the both the process and discrete manufacturing industry. This means the industrial controllers have to be designed to capture the both the data forms, continuous and discrete. Further, with the emergence of computer systems taking over from out data analog controllers, continuous process variables have started to be measured in samples. Thus, the creating a discrete sample data system that approximates the actual continuous system. The one example of a controller that uses the both continuous and discrete control, and where continuous control is achieved using a frequent sampling of continuous data, is the Lego NXT controller installed in the industry. As you can see the image, dear students, this is the XNT controller with three actuators, as you can call motors, and four sensors. In reality, the continuous control systems are often segmented into a smaller parts with many feedback loops, all of which have to be individually controlled and coordinated so as to maintain the overall output variables. The continuous control system are to be found throughout the chemical industry, where many parameters related to chemical reactants such as temperature, pressure, and flow rates must be maintained. They are also to be found in a conventional manufacturing system in certain situations, such as the positioning of work part relative to cutting tool by using the XYZ coordinates. Hope you understand this. Now coming to the continuous control system, what exactly the continuous control system and how it works, dear students. These have their objectives to maintain an output value at a desired level. Often, however, the continuous control system may be segmented into a smaller parts, all of which have to be individually controlled and coordinated so as to maintain the overall output variable. The continuous control systems can achieve its control objective in a number of ways. These includes methods of regularity control, feed forward control, steady state optimization, and adaptive control as mentioned in a coming table. Uh, Dear students, in this table, dear students, we will discuss about the yeah regularity control. First one is regularity control, which is control objectives of the continuous control systems. In regularity control, the objective is to maintain the process performance at a certain level or within a given tolerance bond of that level. The performance measures or the index of the performance is calculated based on the output of several variables. The disadvantages with the regularity control is that compensatory actions can only occur often a disturbance of hot disturbance and not before. Coming to the feed forward control, second objective, the objective is to anticipate the effect of uh, disturbances on the system and to compensate for them before they can occur. uh, Corrective action takes place as the process is ongoing by the corrections of variable that act as a new inputs into the system. The disadvantage uh, is in the resilience upon the measurement of variables in the mid process, which may not be 100% accurate, thus affecting final output variables. The feed forward control obtained combined with the feedback control in many more models to overcome the problems. And third objective is that steady state optimization, open loop control system that uses the performance measures the index of the performance, mathematical models of the process and optimization algorithms to determine the input parameters to drive the process. The control system is effectively separate from the process system and relies upon the quality and excellence of its performance models into input correctly suitable input parameters to achieve the required output variables. The disadvantage is obviously related to the certain and maintenance of such accurate performance models for the control system, which can be affected by the disturbance to the process system not accounted for in the control system design. And the fourth objective is that adaptive control to overcome the disturbance which steady state optimization is prone to. Adaptive control uses feedback control and optimization by combining the both practice. The feedback is provided in its unusual external manner by the system, but the results are then utilized by a control algorithm that attempts to optimize an index of a performance. As in the steady state, the optimization system, thus adaptive control can cope with the time varying environment as its internal parameters and mechanisms are not fixed. It has a three principal functions: the identification function, which determines the current index of the performance based upon the feedback from the process system; the decision function, which determines what changes have to be made to improve the performance and alter the input parameters accordingly, and the modification function, which implements the decision function's output. And the last one output is online research, last objective is online research strategies. The objective is to improve the adaptive control decision functions described above. Sometimes the decision function cannot be sufficiently defined, that is, the relationship between the input parameters and the index of the performance is not known precisely enough to take action. In such a cases, the experiments must be performed on the process to determine the appropriate input parameters to input. The small changes in the experimental input parameters give a pattern or tendency that controls can use to implement the input parameters with the confidence that they are correct. The techniques deployed parameters with the confidence what they are correct. Uh, the techniques deployed in experiments range from the trial and error methods to gradient methods.